Alright, when multiplying two rational expressions, the same rules apply. You want to make sure there's no factors left in the numerator and denominator. But before we look at how to simplify, let's take a look at a basic question. If you're multiplying these two fractions, 4/5 times 3/2, there's essentially two ways you could do it. You could multiply straight across and get 12 over 10, and then reduce and see what goes into 12 and 10, and you would find a common factor of 2, and that would give you 6/5. Now, that may not have been the most efficient way. Some of you may be looking at it and saying, wait a minute, we noticed that there's some common factors we could cancel out right in the beginning. And yes, you're right. If we look at the 2 and the 4, 2 goes into itself one time, 2 goes into 4 two times, and then you can multiply across. 2 times 3 is 6, 5 times 1 is 5, and it kind of just saved you that middle step right there. That's what we're going to be looking for. Are there any common factors crosswise or even up and down when looking at these expressions? So looking at number 1, 15a squared and 5a, I do see a common factor here. And remember, if I think of 15a squared as 15 times a over 14 and 7 over 5a, while looking at the a variables, I can see that one cancels out crosswise. Looking at the number 5, 5 goes into itself one time, 5 goes into 15 three times. Looking at the number 7, 7 goes into itself one time and into 14 two times. So we multiply across and we get 3a over 2, which is what this simplifies to. And we can box that. Now looking at number 2, hopefully something is popping out to you. And hopefully the fact is that we need to factor these expressions before we can start simplifying. So looking at the 5x minus 15, I see a GCF of 5 I can take out. So I have 5 times quantity x minus 3. Looking at the 3x plus 9, there's a 3 I can take out. So I have 3 times quantity x plus 3. Looking at the 4x plus 12, there's a 4 I can divide out, leaving x plus 3. And finally, looking at the denominator, there's a 6 I can divide out, giving me a quantity x minus 3. Now that I've kind of simplified these expressions, now I can see, oh, there are some common factors that I can cancel. Specifically, x plus 3 goes into itself one time, x minus 3 goes into itself one time, and then looking acrosswise, 5 and 6 don't have any common factors, 3 and 4 don't have any common factors, but 4 and 6 do. So I could divide 4 by 2 to get 2, divide 6 by 2 to get 3. Now I multiply across, and I have 5 times 2, which is 10, 3 times 3, which is 9, and there's my simplified answer, 10 over 9. Okay. Those are simple rules with multiplying. Now let's look at what happens when we're dividing two fractions. In dividing two fractions, you have to keep in mind that when dividing two simple fractions, you multiply by the reciprocal of the second in order to simplify. So I'm going to take 4/5, I'm going to multiply it by the reciprocal, 2/3. Now the rules still apply. I could look for some common factors crosswise, but there are none, so I just multiply straight across. 4 times 2 is 8, 5 times 3 is 15, and that simplifies to be 8 over 15. Now when we look at dividing two rational expressions here, we need to keep in mind that we always multiply by the reciprocal, and then it turns into a multiplication problem so we can cancel out common factors. Okay. So, looking at number 1, I see the second fraction. I know I have to use its reciprocal. So this simplifies to 2 minus t over 8 multiplied by 6 over t minus 2. Now, right away here, I see the numbers 8 and 6 have a common factor. 2 goes into both of those, so I can call this 3, and I can call this 4. Now, if I look at these two expressions, 2 minus t, and t minus 2, they look similar, but in fact they're actually opposite factors. I have a positive 2 and a negative 2, a negative t and a positive t. So we learned earlier how you can take opposite factors and make them into the same factor, and essentially all you need to do is divide out a negative 1. So I'm going to divide out a negative 1 from that top expression, keeping that on the outside, and that would leave me with a negative 2 plus t, but I'll go ahead and write that as t minus 2. So now I have negative 1 times quantity t minus 2 over 4 multiplied by 3 over that t minus 2. Now I can see, yes, I do have a common factor I can cancel, that t minus 2. Any number divided by itself is 1. And we multiply across, and we get an answer of negative 3 over 4. Alright, moving on to number 2. Number 2. We know that we do need to multiply by the reciprocal of this expression, but we also need to make sure that we factor it so that we can see any common factors. So looking at 2k squared minus k minus 1, it is a trinomial, so I'm going to go ahead and use the trial and error method. The last sign is negative, so I know that I am going to need a positive and a negative sign. What times 2k, or what times itself gives you 2k squared, and that would be a 2k and a k. And finally, what times what would give you 1? That would be 1 and 1. So I'll put in a 1 and a 1, and I check it. Is negative 2k plus k negative k? Yes, it is. Now I factor the denominator. The last term is positive, so I know that I'm going to have the same two signs, and they're both going to be positive. So I put those in. What times what gives me 2k squared? Again, 2k times k. And then what times what would give me 3? And that would be a 3 and a 1. So I put a 3 and a 1. And I check it. Is 2k plus 3k 5k? Yes, it is. Now I know this one I'm going to multiply by the reciprocal. But I'm going to use the reciprocal and factor in one step. So make sure that you're aware I am doing the reciprocal and factoring it all at the same time. So if I'm looking at this specific term, which I'm going to put up here, the last term is negative, so I know that I'm going to have different signs. So I put in a plus and a minus. What times what gives me 2k squared? This is getting redundant now, 2k and k. What times what would give me 3 would be a 3 and a 1. If I put in the 3 and the 1, I check it. Is negative 2k plus 3k 1k? Yes, it is. And now I need to also factor this top expression. There's two terms, so I'm going to be looking for the difference of two perfect squares. And yes, this would turn into 2k minus 1 times quantity 2k plus 1. So I go ahead and put that in, 2k minus 1, 2k plus 1. And now I can look for common factors to cancel. So right away here I see a 2k plus 1 and a 2k plus 1. I see a 2k plus 3 and a 2k plus 3. I don't see a k minus 1 here, and I don't see it here, so I cannot cancel that one. This k minus 1 is here, but it's not over here, so I cannot cancel that. Now I just go ahead and I multiply. Multiplying it out. And if I multiply k minus 1 times itself, I could just call that k minus 1 squared. And then I need to keep this as quantity k plus 1 times 2k minus 1. K plus 1 times quantity 2k minus 1. And box my answer, and that's it. Okay, moving on to the next one. Now we put them together, and we say, hey, do you know how to multiply or divide and simplify? And really with the division, there's really only one additional step, and that is to multiply by the reciprocal. So why don't you try these two on your own, and then I will, and then you can click on the next video and I will show you the answers.